Let's look at the Mandelbrot set. The Mandelbrot set is the most famous example of a fractal, the best known example. Pick a number z, square it and add z, repeat step 2. If the numbers in the resulting sequence do not go to infinity, then z is in the Mandelbrot set. So for example, let's say z equals 3. Here's what we want. So again, pick a number, square and add, pick a number z, square and add z, repeat step 2. Let me show you what this would look like on the TI. So pick a number z. Let's turn this on. So in this case, clear. Okay, so z is 3. So we just press enter. Enter. So we want to square our previous answer and add z. So what we would do is enter answer squared plus 3. So again, whatever answer we get, we square it and we add 3. And then enter. And then we enter again, because we want to square that and add 3. So we basically just press enter again. And what it does, what the TI does, is square our answer and add 3. When you square 12 and add 3, you get 147. Now we square 147 and add 3, and we get 21, 612. We square 21, 612 and add 3, and we get this. And we just keep going. And oops, overflow. The numbers in this sequence go to infinity, so 3 is not in the Mandelbrot set. Now let's pick a number 0.1. Check out what happens. So overflow, okay, we quit. That's fine. Now what happens with 0.1? So we have 0.1. Whoops, sorry about that. So 0.1. Okay, and then we square that. So we want answer squared. Oops, sorry. So answer squared plus 0.1. Not 21, sorry, 0.1. Okay, answer squared plus 0.1, 0.11. So then it squares that, then adds 0.1, and gets this. You just keep going. And notice that eventually we zero in on 0.11270 16654. The numbers in this sequence do not go to infinity, so 0.1 is in the Mandelbrot set. That's an interesting example. What's really more interesting than numbers like 3 or 0.1 is complex numbers. Complex numbers are the form, well, here's an example of a complex number, something in the form 0.1 plus 0.2i, where I is the square root of -1. Some of you are thinking, oh my gosh, what is this man talking about? He's going over my head. How can you take the square root of -1? Don't worry about it. I'm just going to go through this briefly, but I just want to give you just an overview of it. So don't sweat it if you don't follow exactly everything I'm saying. So more interesting examples when you work with complex numbers and see if they're in the Mandelbrot set. The numbers in this sequence do not go to infinity, and you square it and add z, square and add z, square and add z, etc. But I'm not going to go into that. The numbers in this sequence do not go to infinity, so 0.1 plus 0.2i is in the Mandelbrot set. So there is a way that you can graph numbers like 0.1 plus 0.2i. You would graph them on what's called the complex plane. So for instance, here's the number. Here's 1, 2, 3. Here's I, 2i, 3i. 0.1. So for instance, the number 2 plus 2i, well, here's 2 and here's 2i, so 2 plus 2i would be roughly there. 3 minus 2i would be roughly here. And -1 minus I would be about over here. -3 plus 3i would be about over here. So 0.1 plus 0.2i, here's 0.1. So basically we move 0.1 to the right and 0.2i up. 0.1 plus 0.2i would be about over here. So now let's graph the set of all complex points that are in the Mandelbrot set. Well, we know one of them is this one that we just graphed, 0.1 plus 0.2i. What if you graphed all of them? Here's what you'd end up with. This was our best picture of the Mandelbrot set in 1978. And 0.1 plus 0.2i, I'm not sure where it is. It's probably somewhere about over here. But anyway, you graph all the points in the Mandelbrot set, that's what you get. The computers in 1978 were not very sophisticated. With better computers, we now have much better pictures of the Mandelbrot set. So here's an even better shot of the Mandelbrot set. Now again, the Mandelbrot set is a fractal. You can see this better. What we're gonna do now is, so in this previous shot, So all these points that are in black on the inside, they're in the Mandelbrot set. Now we can color code points that are outside the Mandelbrot set depending on how quickly they go off to infinity. So for example, all these points in black, so these points in black, these are all in the Mandelbrot set. And these points that are not in black on the outside, they're colored according to how quickly those points go off to infinity. Let's zoom in on a portion of the Mandelbrot set. Now again, as we've been talking about, the Mandelbrot set is a fractal. See this little portion over here? Well, first of all, what does the whole Mandelbrot set look like? It looks like a bug. Maybe this is the head of the bug. Now see this portion that I've circled here? This looks like a baby Mandelbrot set. And so does this. Notice that the head of the bug is basically a copy, an exact copy of the bug itself. And this is a copy of the Mandelbrot set. And see this little thing up here? That is an exact copy of the Mandelbrot set. The Mandelbrot set is a fractal. Again, it's self-similar. Parts are similar in shape to the whole thing. And it shows detail at every level of magnification. We're going to zoom in on a portion of the Mandelbrot set, and I'll show you that. So here's a video. This is a cool video. You got to see this. Okay, so what we're doing is we're zooming in on a portion of the Mandelbrot set. Now this is not just some image that's generated by a mathematician because he thought it would be cool. Again, these points, the points that you see are in black, are in the Mandelbrot set. It doesn't matter how a mathematician wanted to do this or how he wanted to color the points. What I mean is, if you see a point that's in black, it's in the Mandelbrot set. Notice how incredibly complicated this is. We're zooming in on just a portion of the Mandelbrot set. Different colors represent how quickly those points go off to infinity. This is just an incredibly complicated set, and it's all born out of that simple procedure: square and add z, square and add z, square and add z. And if it goes off to infinity, it's not in the Mandelbrot set. If it doesn't go off to infinity, it's in the Mandelbrot set. If it does go off to infinity, it's not in the Mandelbrot set. So again, look, notice you zoom in all this way, and again, you get that little baby Mandelbrot set. Just such incredibly complicated. It's amazing. I'm going to wait until we see another little baby Mandelbrot set. Then we're going to quit this. What an amazing, beautiful pattern. This is amazing.